Hi and welcome to Maths class. Today we're looking at rearranging formulas. So before we start learning how to do that, first let's work out what that means. So first of all, what is a formula? Well, a formula is another word for an equation, but it's not just any equation, it's a particular kind of equation. And generally it shows the relationship of two values or more values, more than two, in the world and the way they connect together. So you've been learning formulas for a long time, and quite often you'll learn a formula and then you'll use it again and again. For example, the area of a rectangle is the length times the width. So A equals LW. That's a formula. Every time we need to find the area of a rectangle, we use the formula. So here are some other examples. I've written down A equals a half base times height, a half BH. That gives us, that's the formula for the area of a triangle. So A stands for area, B stands for base, and H stands for height. Here's another one. You know this one, Pythagoras' theorem. A squared plus B squared equals C squared, where we know that A and B are the shorter sides and C is the hypotenuse. Here's one you haven't met yet. You'll meet it next year. X equals negative B plus or minus the square root of B squared minus 4AC over 2A. This is the solution to a quadratic equation. You will meet quadratic equations this year, but not this formula until next year. This one you know, we use it to find the gradient y2 minus y1 over x2 minus x1. And one more, this one you're going to meet later this year. Sine theta equals O over H. O stands for opposite and H stands for hypotenuse. So these are all formulas, and we use them to describe a real relationship that exists in the world. So for example, the relationship here is that if I multiply the base of a triangle times the height, and then I take half that number, I'm going to get the area of the triangle every single time. That's why it's a formula, because it describes some kind of rule or relationship that really does exist in the world. Now here are some key words that we need. Transpose. What we do when we transpose, it's a little bit like solving. So when I solve an equation like 2x plus 1 equals 5, I'm going to rearrange the equation until x is on its own. But if I transpose an equation, I don't have 2x plus 1 equals 5. I might have ax plus b equals c. So I do the same thing, but I rearrange it till x is on its own, and it's not called solving, it's called transposing. And subject, well, for example, in this equation, m is the subject because m is alone on one side. In this equation, x is the subject because x is alone on one side. In this equation, there is no subject. I don't have, even though c squared is alone, it's not c, it's c squared. So c is not the subject. And in this equation, A is the subject. So A is alone on one side. All right, so let's do some examples. What we do is we do it in a very similar way to solving equations, but what we're shifting around is not numbers, but pronumerals. So let's look at our first example. A squared plus B squared equals C squared, and we need to make A, the letter A, the subject. And so we need to rearrange this formula. And we might do that if we had a right angled triangle and we weren't looking for the hypotenuse, we were looking for one of the shorter sides. It helps to have a formula with just A equals, and then we just put the other two values into the formula. So what I'm going to do is I'm going to think about, how do I get A by itself? Well, the first thing I can do is I can rearrange to move this B around. So by rearranging, I'm going to subtract b squared, because plus b squared minus b squared is going to leave me with just a squared. And on the right-hand side, I'm going to do the same thing. I'm going to subtract b squared. This line of working doesn't need to be written down, although you can, but you can just think about it in your mind, okay? This next line of working you need to write. So if I go a squared plus b squared minus b squared, I end up with just a squared on the left. And on the right, if I go c squared minus b squared, I'm left with c squared minus b squared. A is still not the subject. A squared at the moment is the subject. I need to make A the subject. So I need to keep transposing this formula until I get A on its own. So I think to myself, what did I do to A here? I squared it. Well, what's the opposite of squaring? Square rooting. So if I take the square root of this and the square root of this, on the left side I'm left with A, and on the right side I'm left with the square root of c squared minus b squared. So the difference between transposing and solving is I'm not really left with an answer. I'm left with another formula. It's actually the same formula rearranged to look a bit different, but the relationships are all the same. If I got a right angled triangle and I measured the hypotenuse and then I squared it, and then I measured one short side and I squared it and I subtracted that from that, and then I square rooted my answer, I would get the length of the second short side, right? So it's a relationship that's still real. I've just rearranged it. But this is useful because now if I've got a whole lot of questions with a missing shorter side, instead of putting it into this equation, I can put it straight into this. So I have a second example here. A equals a half BH, make H the subject. Now I'm going to show you a different way of doing this if you're feeling a bit unsure. I think to myself, how do I move from H to a half BH? Well, the first thing I might do is multiply by B, and that's going to give me BH. And the second thing I might do is multiply by a half, and that's going to give me 1/2 BH. Then I use backtracking, which we've learned about before, but I'm not going to change that back into H. I'm going to start with A, because A and a half BH, these are equal. So at every step, these should be equal, all right, as I go backwards. So what's the opposite of times by a half? Well, it's dividing by a half, which is the same as timesing by 2. So that gives me 2a here. And then the next step was timesing by b, multiplying by b. The opposite of multiplying by b is dividing by b. So that's going to give me 2a divided by b. I can write as 2a over b. So that gives me h equals 2a over b. How would that look like if I did it as working here? I multiply both sides of my equation by 2. So that gives me 2a on the left and bh on the right. I'm now at this step, 2a equals bh. And now I'm going to divide both sides of my equation by b, because that will cancel out these b's and it will leave h as the subject, leaving me with 2a over b. Okay, so I have answered the question. I've made h the subject. So if I now got told I've got a triangle with an area of, let's say, the area is 6 and the base is 3, I can say 2 times 6 over 3 is going to give me my height. 2 times 6 is 12, divided by 3 is 4. The height is going to be 4. So that's one of the things that's useful about transposing, is instead of substituting into this and then solving, I transpose it first and then substitute into this, which is very quick to solve. All right, I'm going to do another example. This is an equation you all know well. Y equals mx plus c. Do you remember it? This is the equation of a straight line. M is the gradient and c is the y-intercept. So I'm going to make x the subject. So let's think about it. What do I do to x? First, I multiply it by m, then I add c. So let's do the opposite of all of that. The last thing I did was adding c, so the first thing I'm going to do is subtract c from both sides. On the left, this gives me y minus c, and on the right, this leaves me with mx, because mx plus c minus c leaves me with just mx. Okay, so what do I do to x here? I multiply it by m, and that's all. So what's the opposite of multiplying by m? Dividing by m. So those m's will cancel, leaving me with x on this side, and leaving me with y minus c over m on the other side. Oops, sorry. And that's the solution to that. And that's all that you have to do. You don't have to do all this other stuff that I showed you. That's just there if you get a little bit stuck. So what I've done is I have transposed this equation to make x the subject. So this relationship and this relationship is the same. If I put in the same group of numbers, I will get the left side equaling the right side. I've just rearranged it to look different, but it is the same relationship.